Now we're going to be solving the chapter 9.4 till 9.7, I think. I forgot till 9. What is it? Quiz. It's really easy. It's all really talking about gravitational potential energy and mechanical energy and things like that. So we're going to start solving. The diagram below shows a segment of a roller coaster and the mass is 4.5 times 10 power 3. You're going to take G as 10. So now we need to see the only formula we're using here is W equals positive negative mgh. It's positive if it's going down and it's negative if it's going up. So positive and negative. So let's start. So from 1 to 2 its distance is 60. So we're gonna do mass, which is 4.5 times 10 power 3 as it's given, times 10 times the distance, which is 40 plus 20, which is 60. This is gonna give you 5 zeros. This is how many joules, but we want it in megajoules, which means go back 6 spaces. When you go back 6 spaces, you're gonna reach here, so your answer is 2.7 megajoules. Okay, I did something, yeah. So we got this one to be 2.7 megajoules, and C, I'm gonna solve it. Okay, fine, we'll do B first. So now going from B, which is from 2 to 3. Here the distance is going up, so it's gonna be negative. And the distance is 20 meters, so 4.5 times 10 power 3 times 20 times 10, which is going to give you 9. 1, 2, 3, 4, 5. So when you go back 6 spaces, you're going to get 0.9 megajoules, and it's negative, like we said, because it's going up. Now, the work done by the gravity as the train moves from positions 1 to 4. From 1 to 4, it's going down the same distance, which is 60, with the same mass and the same gravitational acceleration. So it's going to be the same answer as part A. Because we know that gravity does not care about the path taken. All it cares about is the level where the end point and the start point is. That's all gravity cares about. So we're done this one. Let's go to the next question. Okay, so now we have this question. It's telling you I have a block of mass 3 kg descending from the top to the bottom of a rough inclined plane at a speed of 1 meter per second. The angle of elevation of the plane is 30 degrees and the length of the plane is 5 meters. We're gonna use G to be 10 meters squared. Now here first I'm gonna add something. It's really important for our exam, and if you know it, you will probably get the answer right most of the time. This here, if this is 90 and if this is 30 and this is 90, this leaves this to be 60. This is a semi-equilateral triangle, and we know that the angle opposite to 30, or the side, opposite to 30, which is this one here, is equal half the hypotenuse, which they gave us to be 5. So this side is 2.5, which is your height. Let's keep this, so our height equals 2.5. Now let's find the total normal reaction. We said normal reaction always is 0. You can't get it wrong. It's always 0. The total work done by gravity on the block. We said that gravity equals mgh is m is 3 kg, g is 10, h we found it to be 2.5. Once you put this all in your calculator, you're gonna get it to equal to 75. And now we know we have friction. Friction is resistive. It's resisting work done by gravity in this case. So if it's resisting the work done by gravity, it's gonna be the exact same in magnitude, opposite in sign. That's it for this question. It's really simple. Move on to the next one. Now the next question, it's telling us we have a box of mass 15 kg. It's lowered through 2.5 and there's 10 is g. This is really straightforward. X equals mgh and 15, 10, 1 and 15, 2.5. This, put it in your calculator, equals 375, which is your answer. That is it. Let's move on to the next one. Okay. So for this question, it's telling us you have a ball of mass 0.2 kg that's projected at your velocity of 10 meters per second, parallel to the ground at a height of 8 meters. The only force acting on the ball is gravity. So let's see what they want. The work done by gravity on the ball by the time hits the ground. So we know work done by gravity means W equals mgh. So let's see. M is 0.2, G is 10, H is 8 meters. Once you put all this in your calculator, you're gonna get 16. That's how you get part A. So this is part A. Now part B, I'm gonna do it here. According to the work energy theorem. What's the work energy theorem? It tells us that it's kinetic energy plus GPE is equal to mechanical energy, I think. Wait, let me just make sure of the formula. Wait, no, it's not. This isn't the work energy theorem. This is mechanical energy theorem. My bad, guys. Work energy theorem is delta KE equal delta KE equals kinetic energy final minus kinetic energy initial. So according to the work energy theorem, the kinetic energy of the ball as it's about to hit the ground is, so we have work done. Guys, you know what? Just forget the theorem. How you do this part is the kinetic energy of the ball as it's about to hit the ground is you solve for the kinetic energy first, which is equal to it's half mv squared. So half of 0.2 times v squared, which is 100, which is 10 squared, but it's 100. It's gonna give you 10. Now when you add 10 to your potential, when you add 10 to your work done, which is here, you're gonna get it to equal 26. And that's how you solve it. I remember there is a law somewhere in my copybook that talks about work and work net. I wrote it I don't know where it went in my copybook. Guys, there's a formula. I'll find it. Wait, let me go find it and then I'll continue recording. You won't feel the difference, but okay, yeah, I found it. I remembered it. It's work equals kinetic energy or delta kinetic energy. I don't know why I wrote it so small in my copybook. Anyways, so work, we found it to be 16, and kinetic energy is equal to kinetic energy final minus initial, and you get the the initial, you got it to be 10. We found it right now from here. And so the kinetic energy final is 26 when you do it. So kinetic energy final equals 26, equals 16, which is your work. So this is 26. Now, part C, I'm going to do it over here. The speed of the ball as it's about to hit the ground is, you take your kinetic energy, go to find speed, the final speed, velocity. 26 equals half, m is 0.2, and v squared, we'll find it. So once you solve this, you're gonna get, let me solve it on my calculator. 26 times 2 divided 0.2 is 260. So v squared equals 260. When you put it under the radical sign, you're gonna get that v equals something around 16. They want the nearest integer, so it's gonna round down or up to 16. And that's it for this question. Okay. So this question is pretty easy. It's just mgh. W equals mgh. The student of mass 40 kg ascends through 50 stairs, each at a height of 30 centimeters. So each of them is 0.3 meters long. And there's 50 stairs. So meaning that if there's 50 stairs, each was 0.3 meters, when you do 50 times 0.3, you're gonna get that you went a total distance of 15 meters. Now we have our height, we have our g, we have our mass. So 40 times 10 times 15 is gonna be 40 times 15 times 10, which is 6,000. And they want it in kilojoules, so you remove 3 zeros, it is just 6. And that's it for this question. Let's move on to the next one. Okay, so we have a construction worker that is 90 kgs and moving through the floors to the unfinished building. The height of each floor is 4 meters. So this is 4 meters, this is 4 meters, this is 4, this is 4. The reference level is this. So this is your 0 level. The reference for the gravitational potential energy is first floor, and take G to be 10. So gravitational potential energy of the worker standing on the ground floor. If the worker is standing on the ground floor, he's standing underground, under the reference level. So if he's standing under your reference level, it's gonna be negative, obviously. But let's calculate how much negative. W equals mgh. If your distance is 4 meters, your g is 10, and your mass is 90. You're gonna get 3600. We said that's negative because he's under reference, and you want it in kilojoules, so it's 3.6. So negative 3.6. The gravitational potential energy of the worker standing on the first floor. If he's on the first floor, then, and the first floor is the reference, it's gonna be 0. You don't do anything. The reference level is always 0, the gravitational potential energy on it. Now let's see the next two parts, what they want. If he's standing on the third floor, so if this is your reference and this is your 0 meters, this is 4, another 4 is 8, another 4 is 12. So this is at a distance of 12 meters from your reference level. If it's at a distance of 12 meters, then you're gonna do 12 as your height times 10 times 90. Which, when you do it on a calculator, you're gonna get it to be 90 times 12 times 10, which is 10800. No, wait, what? You don't get that. Wait. Guys, wait, I wrote the distance is wrong. This isn't at 12 meters. Because if this is your 0, this is 4, and this is another 4, so it's just gonna be 8 meters. I don't know where I got 12 from. So 8 times 10 times 90, it is 7200. They want it in kilojoules, 1, 2, 3, so 7.2. And since it is above reference level, it is positive. See? Positive 7.2. And that is it for this question. Let's move on to the next. So which statement is true about gravitational potential energy? So we know that the GPE is proportional to the mass. Why is this? Because W equals GMH or MGH. So it's, if they're on both either sides, they are proportional. But but G is inversely proportional to M and G is inversely proportional to H, but it is proportional to the GPE. Oh wait, they said mass, not G. Sorry, so W is to M, same. They're both on either side of the equation, so it is proportional. GPE is always given with respect to a reference level. Yes, memorize it. It is always given with a reference level. Always. An increase in GPE is equal to the work done on it by gravity. So, no, it's not. It's equal to the negative work done by gravity. Because we know that that GPE and gravity are opposite. So increase in GPE equals decrease in gravity, negative work done by gravity. As you can see in this option, change of GPE equals the negative of the work done by gravity. GPE is proportional to the square of its speed. Nothing mentioned speed in this equation, so definitely not. Let's move on to the next one. The mechanical energy of an eagle flying at a height of 3 meters is 3 times the gravitational potential energy. We know that mechanical energy equals kinetic energy plus potential, or well, GPE, because this is the only type of potential energy we're taking in this chapter. So mechanical energy of the eagle is, okay, so we need to find the mechanical energy, but they told us it's 3 times gravitational potential energy, and they didn't give us any velocities, so we cannot find KE from this. So what we have to do is we find gravitational potential energy and then multiply it by 3. So how do we find GPE? It's equal to MGH. MGH is 4 kg, 3 meters and 10. So 4 times 3 times 10, it's gonna be 120. So if this is your gravitational potential energy and they told you your mechanical energy is 3 times it, so you take this multiplied by 3, you get 360. 360 is your mechanical energy. That's it for this part of the question. Now for the second part, we already said that mechanical energy equals kinetic energy plus GPE. And if you want to find speed, you need to find kinetic energy first. So what we do is, if this is 360 and this is KE and this is 120 as we found, then KE equals 240. Now that we have our kinetic energy, we could use it and substitute the equation. Equals half our mass, which is 4, and V squared. Now let's see. 240 times 2, which is 480. 480 divided by 4. V squared equals 120. So since it's equal to 120, V equals radical 120, which is gonna give you, I think, 10 point something 9 or something like that. But let me make sure. It's gonna give you 10.95, which you could, it's around 11. You round it up to the nearest integer, which is 11. And that's it for this question. Let's move on to the next. Okay. So for this question, we're gonna solve with the conservation of energy principle. You have a puck that is 200 grams, so 0.2 kilograms, and it's a smooth curve shape. When you have a smooth surface, we know that kinetic energy is equal to potential energy. So, sorry, it's equal to W, not it's not potential energy. My bad. So now you have your mass, and we want to solve using the this, which we know W equals mgh. So let's first solve using mgh. You have your height, which is 0.8. So you do 0.2 times 0.8 times 10. So 0.2 times 0.8 times 10 gives you 1.6. So that is delta KE. We know delta KE is the same as kinetic energy final minus kinetic energy initial, which we could substitute this by writing 1.6 equals half, not yet, v final squared minus v initial squared. So what we're gonna do here is we're gonna substitute the m with 0.2, and we're gonna substitute v initial squared with 0, because why? Point A, the block is at rest, so you don't have a velocity initial, it's at rest. So we're gonna substitute this with 0. Now once you solve for this, you're gonna see that when I'm gonna do it on my calculator quick, times 2 divided by 0.2, velocity final squared equals 16. So radical velocity final equals 4. So that's how you get part A. Now at point C, we need to find it at point C. Now let me just refresh the screen so we can start solving fresh screen. Now again, we have to use our same equation. Delta KE equals W. We found our W to be 1.6, and now we have a new kinetic energy thing. It's the same formula, which is half V final squared minus V initial squared. But we have a new V initial, since it's starting at point B, and the speed of the puck at point B was 4. So this is your new velocity initial. So we're gonna replace this by 4. So, and this mass, it's gonna stay 0.2 kilograms. So again, we're gonna get this equals 16 equals velocity final squared minus 16. So what can we see here? That when you move it, but wait, C is going up, C is negative. So since it's negative, this is negative, what's it called? Negative 16. So now that when we move this, you're gonna get 0. So V final squared equals 0. So your speed of the puck is 0. So now for part C, let's solve. Okay, so for part C, they're telling us that now your track is not smooth. If it's not smooth, mechanical energy initial is not equal to mechanical energy final, because that's your case when it's smooth. But since it's not, we need to calculate the difference between them. So we need to calculate delta mechanical energy, which is mechanical energy final minus mechanical energy initial. This is when they tell you some of it was lost as heat. So let's first find mechanical energy initial, which is at point A. Mechanical energy, we know that it's kinetic energy plus GPE initial. So our GPE is, our kinetic energy, by the way, here is 0 because it's at rest. So this is immediately 0. And GPE is gonna be 0.2 times 10 times 0.8, which I'm gonna really quickly do on my calculators. 0.8 times 0.2 times 10, which is gonna be 1.6. So our mechanical energy initial, I'm gonna replace it with 1.6. And we know our mechanical energy now, the change of it is 3 meters. Wait, no. Sorry. So mechanical energy final, now we need to find it. It's at here. So here our gravitational potential energy is on the reference level. So it's 0. So it's gonna be kinetic energy plus GPE, which is 0. But let's find kinetic energy. Kinetic energy, we know that it is equal to half times mass 0.2 times velocity final. Velocity final is 3 because now they told us it is not smooth and the speed is now 3. So we're gonna have to find it. Since it's not smooth and it's 3, let me calculate it really quickly. 0.5 times 0.2 times 3 squared, which is 9, is 0.9. So since it's 0.9, we know that divided 1.6 is, now we can replace this by 0.9, and when we do it we get it to be equal to 0.7. And if they asked you how much mechanical energy is, it's negative 0.7, but they asked you lost, they told you it's lost, so they told you it's negative, so it's just 0.7. That's it for this question. Let's move on to the next one. Okay, so you have okay, so this question, it's not really a concept we took in class, but it's not that hard to solve either. So what we do is we read the question. So let's see. The 200-gram bob of a pendulum, so it's 0.2, or is it, yeah, 0.2, of length 0.8. Wait, is this, if it's with the vertical, then this is your height, but let's see, if 0.8 is projected 2 meters per second horizontally, so it is not with the height, this is your length, not height. I'm not gonna write not as x. So 0.8 is your length, so we need to find the height, because they don't give us a height, is from its lowest position. And here they want the cosine of the maximum angle theta. So maximum angle means that kinetic energy equals gravitational potential energy equals GPE. So what this means is we need to find our height first. To find the height, we need to find the kinetic energy, because we have a velocity, but we don't have everything needed for height. So let's see. So kinetic energy equals half, m is 0.2, and v squared, which is 2 squared. When you put it into your calculator, you're gonna get 0.5 times 0.2 times 4, which is 0.4. So your kinetic energy is 0.4 and your GPE equals 0.4. Let's write GPE equals mgh. So our mass 0.2, our g is 10, and our h is what we need to find. So now when we do this, you're gonna get h equals to, wait, let me do it on my calculator. 0.2 10. Our h is 0.2. So now that we have our h, we're gonna have to do this one formula to find the cosine of the maximum angle. Memorize it. I don't think our teachers, or I don't think it's written in the book anywhere, but memorize it. It's equal to 1 minus small length, which is 0.2, over big length, 0.8, because this is our length. We said that already. So once you do 0.2 divide by 0.8, you're gonna get that this is equal to 0.25, and 1 minus 0.25 is gonna give you 0.75. That's how you find the maximum angle. Be careful, don't memorize this. So it's small over big and subtract it from 1. So this is the cosine of the maximum angle. If they asked you what is the maximum angle, you're gonna have to do cosine -1 of 0.75. So, which is just shift cosine on your calculator, 0.75, which you'd get to be 41.4, but forget this for now because they didn't ask it in the question, and this question I am almost 100% sure nothing like this is gonna come in our exam, but just in case, know how to do it. Next question. Now you have a ball of mass 1.2 kg vertically 2 meters above the ground at 5 meters per second, and yeah, they want the mechanical energy. We know mechanical energy equals kinetic energy plus GPE. So let's first find GPE, which is mgh. This equals mgh. So mass is 1.2 times 10 times h, which is 2. You're gonna get 24. Now let's find the kinetic energy. Kinetic energy equals half 1.2 times velocity squared, which is 5 squared. Once you do this in your calculator, it's gonna be 0.5 times 1.2 times 25. It's gonna be 15. So kinetic energy equals 15. Now we need to add the two. 15 plus 24 equals 39, and that's how you get the answer to this question. Now let's move on to the next one. Okay, so in this question they're telling you have a block of mass 1.6 and it's projected up a smooth inclined plane at 3 meters per second. It comes at rest at the top, so it's at rest, so the kinetic energy here is 0, and at position 2, this is position 2, and you take the reference level of gravitational potential energy here. If this is your reference level, then here GPE is 0. And so let's see. The initial mechanical energy of the block is, so mechanical energy equals kinetic energy plus GPE. So the initial, which is here at 0.1, is gonna be kinetic energy plus, we said GPE is 0 because this is the reference level, so we just need to find kinetic energy, which we do by doing half the mass 1.6 times v squared, which is 3 squared, multiplied by here, so 0.5 times 1.6 times 9 is gonna be 7.2. That's how you find the answer to the first part. Now, the mechanical energy of the block at the top of the inclined plane. Let's solve. So at the top of the inclined plane, we're gonna do the same thing as here, except here we need to find GPE, and we put kinetic energy as 0 because it's at rest at the top. They mentioned this, it comes to rest at the top. Because of this, we need to find GPE, which is equal to mgh. So let's see, m is 1.6 times g, which is 10, times h. We don't know h, but we know that the rule is when it's a smooth inclined plane, kinetic energy, it's that mechanical energy initial equals mechanical energy final, because it's the conservation of mechanical energy. So if your initial was 7.2 and then all that changed, it was a smooth inclined plane. This is important. So the mechanical energy at the top and at the bottom is gonna be the same, 7.2. Now for the last part, we need to find what's the height. So 1.6 times 10, we already agreed on this, times height equals to 7.2, which is our mechanical energy. Or well, like the mechanical energy. So once you solve this, it's gonna be h equals 7.2 divided by 16, which is 0.45. That's it for this question. Let's move on to the next one. Okay, these questions are now really easy. So a pump is used to lift 200 kg of water by the height of 0.6 in 2.5 minutes, and g is 10. So let's find work. Work against gravity is mgh. So 200 times 10 times 6 meters. Once you do this, you're gonna get it to be 12000, and they want it in kilojoules, so you remove 3 zeros, it's just gonna be 12. Now you take this number with the 3 zeros and you divide it by your time, but you have to make the time in seconds. So you need to do 2.5 times 60, because there's 60 seconds in a minute and there's 2.5 minutes, so it's 150 seconds. So you divide this by 150, you're gonna find that the power delivered is 80 watts. So this is equal to 80, and that is your power, because power is equal to work over time taken. Now let's move on to the next one. Again, power and work. So a car is moving at a constant speed across a horizontal road. The engine exerts a force of 5 kilonewtons, so 5,000 newtons, moving the car through 880 meters in 80 seconds. So mgh, well, you don't need to do mgh because they gave you a force. It's just work equals force times distance here. Because we know that when they give you in newtons, it is your force. So now we do 5,000 times 880. You're gonna get, when you do it on your calculator, you're gonna get, let me erase this, is 4 and 1 2 3 4 5 zeros. So it's once in megajoules, so you remove 6 of those you remove all 5 zeros and move it all the way over here, so it is 4.4. But knowing we need to calculate power still, we bring back the original number, which is this, and divide it by the time, 80 seconds. You're gonna get it to equal 55000, which you remove 3 zeros because it's kilowatts, so you're left with 55. And be sure you look at significant figures because they're really important in the exam. Could cost you all the exam. Now let's move on to the last question, which is again power. Column lifts 320 over 12 floors in 120 seconds. Each floor is 3.2 meters. So we need to find our height. So if there's 12 floors and each one is 3.2, you do 12 times 3.2, which is equal to 38.4. So you take your height, which is 38.4, times 10 times 320. You're gonna get a number that is 122,880. You take this big number, you divide it by the time taken, which is 120. You're gonna divide this all by 120. When you divide it on your calculator, this is gonna equal to 1024. And that is it. We're done this quiz. It has a few tricks and questions that are confusing, but if you understand the way of solving them, you should be able to solve any type of question in the exam, because you usually know that the course practices are way harder than the actual exams. But that's it for now. I hope you have a nice day. Bye.